Thank you for giving me the platform to share my research that I've been working on for the past year. As Corey mentioned, my research was on detecting greenhouse gas emissions from textile waste under ultraviolet weathering, and this is an emerging climate impact of the fast fashion industry. I hope by the end of my presentation, you could better understand how the clothes that we buy, wear, and end up discarding can contribute to the climate crisis, and hopefully you leave with a few solutions that you can implement in your daily life. I would like to thank my advisors, Dr. Dehane and Dr. Rue, for facilitating this research and taking a leap of faith for a non-scientist to take something like this for their research project. All right, so has anyone heard of fast fashion? Yes. So fast fashion is the rapid production of low-cost, low-quality clothing, mostly made of synthetic fibers. 59% of our clothing is made out of polyester. This is a synthetic textile derived from fossil fuels, similarly to plastic. So prior to the 1990s, we had 2 to 4 seasons every year. These were meticulously designed and sourced from good quality garments that would last generations, and you could have hand-me-downs for your kids. That doesn't really happen anymore. We have now 52 micro seasons a year. And companies such as Shein actually produce 6,000 to 10,000 of new garments onto their website every single day. I just wanted to highlight that our most accessible brands that we have in our malls and online have succumbed to the fast fashion model, because slow fashion and good quality takes time and a lot of money, but you invest in these clothes so you can then have them for a long time. So many companies that used to be good quality and were slow fashion have now succumbed to the fast fashion model. This fast fashion model promotes a take, make, and dispose economic model where it's now cheaper to buy new than to fix old. This is causing a huge overconsumption issue. The average American buys 65 new items of clothing every single year. 50% of that will be discarded in just 1 year. That's a lot of waste. That equals to 92 million tons of textile waste produced annually. That's kind of an abstract number. What does that equal? That's 1 garbage truck's worth of clothing getting dumped or incinerated every single second. So where does all of this textile waste go? Here I've highlighted countries in the yellow, so countries such as Chile, Ghana, Nigeria, Kenya, the Philippines, and countries in India receive these secondhand clothes thinking that they can make a new life and not end the life of the garment right there and then. But with the rise of ultra fast fashion and fast fashion, these are ending up in open air landfills. So the countries in the global north, such as the US and countries in Europe, have engineered landfills where we can capture the gases that are getting emitted and reuse them as energy. That makes sense, but a lot of these countries don't have that infrastructure, so these emissions are going straight into our atmosphere, contributing to global warming. So my research question is, does textile waste emit greenhouse gases under UV weathering? Why would I ask a question like that? Well, there's 2 studies from Royer et al. And Shaw et al. That have found that low-density polyethylene, which is one of our most abundant plastics, these are our soft plastics from plastic bags and water bottles, emits a significant amount of methane and CO2 just under UV light. So this is not a biological process. This is just UV weathering on these plastics. And so we're curious if this polyester, which is different from plastic, but similarly derived from fossil fuels, will it emit a significant amount? We're also testing if polyester and cotton has a difference, because cotton is a natural fiber. But in the fast fashion industry, there's over 10,000 additives that we don't know a lot about, and they're trade secrets, and so perhaps that can outgas something as well. And so here is our picture of our water bottles that are emitting these greenhouse gases, and then those are our polyester clothes that are getting dumped, and we're wondering, will these emit a significant amount? So how did we do this? So we had yellow and black polyester versus yellow and black cotton, just to have the same variable in colors. And we degraded them for either no weeks at all, so non-degraded, or 1, 2, or 3 weeks of degradation. Then we put this in a sealed enclosure. Shout out to my dad who built this for me. And this is UV transparent, so we would put the textile in here with either dry condition or wetted condition with H2O or hydrogen peroxide to simulate a natural environment when H2O, UV, and organic compounds react together. And then we closed this sealed chamber, connected it to the LGR analyzer that produces CO2, carbon monoxide, and CH4 time series, and then we put them with and without UV to see if UV is driving these emissions. And so, were we able to see emissions? Yes, which is exciting, but also a little evil. But here, I wanted to show you on the x-axis, we have our dry condition, H2O condition, and hydrogen peroxide condition. And then the pink is our UV variable. So as we can see, the green variable, non-UV, is not emitting emissions. So we can tell that UV is driving these emissions up. And what we can see is that our H2O2 condition for yellow polyester is emitting the most amount of methane. We're particularly interested in methane as climate scientists because methane has a global warming potential 80 times greater than CO2 on a 20-year time scale. And so why is H2O2 emitting the most? But because when UV light and H2O, or in this case, H2O2, react, they create hydroxyl radicals, which is OH. They can attack these additives or the polymer chains. This creates chain scission, where the backbone of the polymer breaks apart and then carbon released as greenhouse gases are emitted. Here I wanted to show you yellow polyester versus yellow cotton. And here you can see this is our yellow polyester and yellow cotton. And what's really interesting about this is our yellow cotton, the natural fiber, is emitting a significant amount of methane and CO2 and carbon monoxide. But our synthetic is emitting much more. One of the interesting findings that we found is this U-shaped plot. A hypothesis of why it could look like this is that on our x-axis we have day 0 of degradation, so not degraded, then 1 week of degradation, 2 weeks of degradation, and 3 weeks of degradation. And all 4 of these lines equal our yellow polyester, our yellow cotton, our black polyester, and black cotton. And so one thing the reason we think that this is happening is that on the left here we have unweathered, so we can see this is very pigmented, much more than the one on the right, which is 3 weeks of weathering. And the difference is that a lot of the dyes have already outgassed. So what we're thinking at day 0 is this initial enhancement when it's with UV. It emits these additives and these dyes for the first 16-minute trials. And then by week 1 and 2 of degradation, those additives are already gone. And by week 3, we can assume that the UV penetrates to the polymer, breaking the polymer and then releasing these gases. This is a hypothesis of what this could look like. Royer et al., who found that low-density polyethylene emitted methane and CO2, had a 212-day study where the methane exponentially grew over the 212 days. So perhaps if we kept this in the UV chamber for weeks, months to years, it would continue to outgas, maybe to look like a Nike sign. So this is, of course, a laboratory study. This is a controlled setting where we have the control of what textiles we use, how much UV exposure, what the temperature is like. But the real question is, does this happen in real life, in real places that get all of these textiles? So Dr. Dehane and I had the privilege of researching in Accra, Ghana. Ghana is a country in West Africa, and you might wonder why Ghana. Well, Accra is one of the leading importers of second-hand textiles in the world. They receive 15 million garments every single week, yet due to fast fashion, 40% gets landfilled or incinerated immediately upon arrival. So as you can see, this is Jamestown Beach, completely covered in textile waste because these textiles have nowhere to go. They don't have the infrastructure, so they end up in their ecosystems and in their neighborhoods. This is in the middle of a neighborhood in Accra, and this is an illegal dump site called Old Fatima, where we were able to take our measurements. So we took flux chamber measurements here with a fancy mop bucket, and we pulled 1.5 liters of air into these air sample bags, which are kind of look like Ziploc bags that we then sent to SIO to analyze the same way we analyzed our control. And then here we had a metal pole and a little string that had our tubing where we took air samples right above the lagoon because it's very polluted with textile waste and plastic waste, and we wanted to see if it would emit higher amounts of methane and CO2 and carbon monoxide. So we had 9 sites. This is a picture of Accra, and we started at Contamonto Market. And Contamonto Market is truly an incredible place. It recirculates thousands of clothes. It's filled with sewists and tailors and upcyclers and recyclers who try to give a new life to these garments. And they did this before around the 1990s. They were really able to execute this well. But with the rise of these petroleum-based fibers, it's really hard to recycle, and it's really hard to make something new out of them because they're so stretchy, they break, and it's just not good quality. And then we went to Old Fatima, like I mentioned before, and as you can see, it's along a lagoon, so anything that falls out of the lagoon is falling straight, whatever falls out of the dump site falls straight into the lagoon. And then we had 4 different sites along the lagoon. Here you can see this water is extremely stagnant, not really moving how a lagoon should flow. This is a lot of plastic debris, and lots of textiles are polluting this lagoon here. This used to be a fishing hub and a recreational swimming place. As I mentioned, this is Jamestown Beach. What's really interesting is that no textiles are dumped at the beach. What actually happens is that the lagoon spews into the Gulf of Guinea, and then circulation is recirculating the clothes onto the shore of this beach. This beach is cleaned up every single week. 30 tons are picked up out of this beach every single Tuesday. But it just keeps on recirculating due to the abundance of textile waste. Here, I just wanted to show you all what I was seeing. What you're seeing at the surface is called ebullition, methane bubbling up from the sediments below. Years of accumulated textile waste, plastics, and organic debris create oxygen-free conditions at the lagoon floor. In these anoxic sediments, methanogenic microbes break down organic matter and produce methane, which builds up and escapes as bubbles. While plastics and synthetic textiles are not the main food source for these microbes, they help trap organic material and maintain the conditions that support continuous methane production. So what was once a fishing lagoon and recreational swimming is long gone. And here, to just give you a better idea of what we looked like in the field with citizen scientists from the Orr Foundation, this is us on Jamestown Beach, taking our syringe samples. And this was once a beautiful beach that people got to hang out on and play soccer on, and they can't do that anymore. So what are my results? So here is my lagoon transect, all the blue bar graphs. And then there's Old Fatima, the dump site, and then the purple is Contamonto Market. What I want you to look at is the yellow arrows and the black line. This is the atmospheric background, so the average background of these gases around the world. So the atmospheric background for methane is 2.03 parts per million. You can see that one of our sites on the lagoon is up to 55 parts per million. That's 28 times the atmospheric background. This is extremely dangerous and unaccounted for. Here for CO2, it's relatively high, and especially high at Contamonto Market, and especially for carbon monoxide as well. This could be due to the burning of the synthetic textiles that are done around Contamonto Market. So what are our main findings? Textile waste accumulates in open-air landfills where weathering generates GHG emissions that are currently unaccounted for. Production of GHGs from textiles has 2 phases, within minutes due to the additives, and again after a few weeks due to outgassing of the polymer, a hypothesis of our U-shaped plot. So a few policy recommendations. The 3 most important things we need right now to combat this growing issue is traceability, continuous monitoring, and financing. Here you could see me standing on a pile of textiles at Jamestown Beach. And so the importance with traceability is that we donate our clothes to Goodwill or charity shops. Only 20% of that gets resold. The rest, 80%, gets sent on the global market where there's no traceability. These are trade secrets. We don't know what country's getting what. And in order to get producers responsible for these garments, we have to understand where they're going. And right now, the EU has the digital product passport, which is shown here. It's a QR code that tells you exactly where your fiber was milled, what dye and additives are on your garment, who manufactured it, who produced it, and how to take care of it for the end of its life. And this is important and great and a great starting framework, but once it leaves the EU, no one has the infrastructure to understand this QR code or deal with it because it's getting sent in bales to countries in the global south, such as Ghana, who are just opening them and trying to resell them. And if they can't, they end up in the environment around them. Secondly, we need continuous monitoring. As we saw in the RU lab here, is that we saw enhanced GHG emissions, and we also saw them enhanced in Ghana. And we need continuous monitoring and financing to continue this monitoring so we could see if it's getting worse and get gas flux chamber measurements so we can better understand and quantify textile by textile how much these are emitting under the sun. And right now, all of our GHG emissions for landfills in the global south are estimates per capita. But of course, those are on engineered landfills. But they have these open air landfills that are going straight into the atmosphere, these GHGs. So it's a very lowballed number. Lastly, we need financing. Some of you may heard of EPR, Extended Producer Responsibility. Senate Bill 707 just got enacted. It'll get enacted next month, and it gets the producer responsible for the end of the life of a garment. But again, this is happening in California right now, but once it leaves California, that ends the end of the life. But we know it has a whole nother life once it leaves California in these global south countries. And we need to support local NGOs such as the Orr Foundation. They collect tags from every single garment that they find on the beach, and they write reports to try to get financing from these big producing companies that are polluting their beaches. So we need to support these companies so they can get financing and really do real science and get jobs for these people on the ground instead of picking up trash from their beach. Lastly, I want to just leave you with, you don't need to be a scientist or activist or politician to make a difference. You can buy intentionally. You have the power to choose who you buy from or what you buy. Buy secondhand, buy from your closet. You already might have a lot of clothes. And this photo is from the Tide Turners, and this is them picking up the 30 tons of clothes every single Tuesday. And I hope this wasn't depressing, but rather inspirational and educational that we can make a difference. And thank you so much to Dr. Rue and Dr. DeHane, my amazing cohort, my parents, Ollie, Jada, Corey, and Mark. You guys are amazing and have changed the trajectory of my life. And I'm so grateful to be here today to share my research. Thank you.
Thanks for a great presentation, and I commend you for also taking the laboratory into the field and turning it into something practical. I'm very curious, in Ghana, do you see any local programs or policies or regulations aimed at addressing this problem in addition to the Tide Turners?
Yeah, so Dr. DeHane is actually a leading scientist for the Orr Foundation, which is a local NGO, environmental justice group. And they actually have this program for kayaye, which are the women who carry these bales. And they try to get them to not have those jobs and instead get them jobs to learn how to sew and upcycle and work for the Orr Foundation and create a more sustainable job for them instead of carrying these heavy bales that are just like waste. And they have an immense amount of upcycling. They have all of these denim clothes like made out of clothes that they couldn't repurpose in another way, and they recycle them and make something new. They remanufacture the clothes, they compress them and make speakers out of them and furniture. So they have a lot of on-ground, like Ghana is doing an incredible job, but just the abundance of clothes that we're sending that is bad quality is ruining their economy and their system that they already built there. Thank you so much.